Hi, everybody. Thanks for having me. Yeah, I'm Scott Reinhard. I'm a graphics editor at the New York Times. I'm going to be talking about mapping fog in San Francisco, a story I worked on last year, and I found the order really interesting. Prior to the story, I'd spent 6 months mapping the buildup of Russian forces around Ukraine and the invasion. So this was a bit of a change of pace for me to stare at clouds and fog after that. Yeah, so I worked with the climate desk at the Times and with the Pulitzer Prize winning reporter John Branch on this story. You know, I'm from the Midwest. I know as much about fog in San Francisco as anybody from the Midwest, you know, which is not that much. And what I do with a lot of the work I do at the Times, you know, because we're kind of pulled into so many different things, you're just like constantly learning. And one of the ways I learn about a subject is through making. And so for this, I really wanted to understand, like, yeah, why San Francisco? Like, how does this all come together to create this like particular phenomenon in this particular place? And so I'm going to do two things with this talk. I'm going to take you through kind of my dive into the data that supports this, and then I'll show you, you know, the work that came out of that. When you talk to fog experts about why fog forms and why in particular places, they kind of come back with a few things: ocean temperature, air pressure, wind, and, you know, geography, the coastal elevation, that kind of thing. And you know, and I said, great, okay. Now I want to like actually see it. I want to like go into the data. I want to see that emerge if it does, you know, and kind of like really internalize it for me. The other thing I wanted to do with this was work at various scales, right? So like global level, you know, so here we're looking at wind. And wind is a really good stand-in for like just general weather systems. But, you know, from global level kind of down to very local level. So this is fog rolling in and then rolling out of the Bay Area. This is GOES satellite animation. One of the things I kind of run into when you're working with this type of data and you're wanting to make animations are essentially lots and lots of still frames, so lots and lots of maps essentially. You know, this is the type of data too that isn't particularly meant, I don't know if I'd say meant, but meant to turn into movies. It doesn't come off the shelf as a video file. And so I also needed to figure out what data was appropriate to show these different, you know, parts of the weather systems. And some of these can be pretty dense and you really have to pull it out just to get to a certain point of like judging, does this make sense to use in this particular context? So anyways, this is a screenshot of, I found it, because I was processing so much and so many frames, I actually found it really helpful for me to see all the GDAL scripts that I'd be running kind of in one place. But it worked, you know. I was able to, from these pretty, sometimes really heavy gridded raster data sets, multivariable, some frames, you know, you're downloading just like gigs and gigs and gigs and gigs of data. But I was starting to get things like this, right, where I can like see patterns. And one of the things I do is, is really I'm looking for patterns. You know, and for this one in particular, this is sea surface temperature. The experts will tell you that, you know, the coast of the west coast of the United States is generally cooler and colder, which is one of the reasons that there's fog. And so this was kind of one of the examples of where that is the case. And then this is just another data set, a little more like less average and finer, closer in. And yeah, I was like, oh, okay, yeah, I am really starting to see that, you know. It's not that I didn't believe the experts, but I guess I just, to visualize it, I think, I don't know, I see myself kind of in the reader's perspective too, kind of coming into this clean and when things emerge and I have the aha moment and it like clicks for me, that's usually generally a good sign that it might click with a wider audience too. This was like looking at air temperature at one point in time throughout the atmosphere. This was another way of looking at that. I was just like kind of considering, could I like make a volume of this data? This didn't make the cut, but I like this form. I think it's pretty interesting. It'd be really cool if it was also animated at the same time. But this was looking at ground temperature. So the Central Valley of California is hotter than the coast, and that temperature differential is one of the reasons that fog is pulled in through the bay. I guess I should also note too with these visualizations, like as I'm going through this process, I don't really have the expectation that like, this semi-wacky, animation is going to be published. Like that's the furthest thing from my mind at the moment. It's mostly just like understanding what's happening. And sometimes I'll make things fast so that I can just like, again, see patterns emerge. That's really what I'm looking for in this process. This was looking at air pressure, like high and low air pressure. Air pressure was kind of an interesting concept to try and conceptualize or try to visualize. And you can start to just see some of the refinement also as I get like a better handle on the data and that kind of thing. And then one of the questions too is like, well, how do you show this? Like this obviously did not publish, but one of the questions, one of the things is like, do I show all these elements together? Once I like find the parts, of fog that make it up, does that all go together in something like this? And you don't know unless you try. And so I tried, and it looked like this, and I love how that looks, but not to publish in the New York Times. And so, but I kind of came to the conclusion this is going to be something that I think would be better to step through, because really my goal with this is taking very complex data sets and very complex concepts and doing it in a really kind of intuitive way, as you'll see. So again, fog forms in particular places generally. This is where consistent fog is, generally on the east side of the world's oceans. We were, I don't know what the right word is. We got to work with this really wonderful data set by Dr. Rachel Clemshaw. And what she had done was take 25 years of GOES satellite data and wrote an algorithm that looks at each pixel and says, is this fog or is this not fog? And so we had 25 years of that at our disposal, and we could do different things with that. So in this instance, we averaged it out by day, and then I was able to animate that. And so you're able to see the progression of fog density, I guess, over the course of a summer, starting in Southern California, generally called like June gloom, and then working its way up the coast. And this is another way of looking at that. We took all 25 years of that data and just flattened it into one frame because I wanted to look at the comparison of where historic redwood habitat was and fog, because they have redwoods depend on the moisture of fog. And then the next few frames will be kind of the elements of coastal fog that I'll step through. I wanted to kind of like set the scene for the viewer though, and just show a pretty straightforward, I had made an elevation, but then layered some GOES data on top of it, GOES animation. And I get GOES is the satellite that's about 22,000 miles away, geostationary orbit, so it's always in the same place, taking a photo or in measurements of the Earth every 10 minutes generally. Which is really wonderful. You get really nice animations out of that. There's a high pressure system in the Pacific Ocean called the North Pacific High, which is relatively stable. And in my explorations, like how to show air pressure, I think I came to the conclusion, like, actually, I don't need to show it. I need to show its effects. And what the effects are the wind. And so you have these winds that are just moving in clockwise fashion. What this does is it pushes warmer water down and away from the coast, and it allows cooler water to rise to the surface. That cooler water cools the air and forms fog. One of the things, though, that happens is all this fog forms along the coast, but then it bumps into the coastal mountains along the west coast, except for the Golden Gate, right, which we know from the bridge, but is also a geographical feature that's a gap in the mountains. And because of this temperature difference that I was talking about a little bit ago, it pulls in the fog, right? And so you have this place where this fog is coming through. And so that's like kind of why San Francisco and fog are so linked up together. The other thing I'd like to say about this is, I was really conscious about the amount of information I was giving here. And I was like, so for this and maybe others, I was like less concerned that this particular blue equaled 40 degrees Fahrenheit and this orange equaled. It just wasn't particularly relevant. I was like maybe a step above that, where it's just like, this is hotter and this is colder, and that's all we kind of need to talk about at the moment, and to illustrate this concept. This is that same 25-year data set, but by hour. You can see, over the course of a day, on average, where fog kind of forms and goes away and forms and goes away. This didn't publish. This was a sketch that I made to get some outside help. So I really wanted to see, I also heard about all the microclimates of San Francisco, and different neighborhoods are cooler or warmer, have fog, don't have fog. And I was like, okay, how can I see that? The problem is the data sources are a little too coarse to kind of get to that level of detail. And I had thoughts too, like, oh, maybe we put real estate prices with fog and make that link. Anyway, so that, which I think there is some correlation, but it didn't go anywhere beyond that. But with that sketch, I was able to get some help with my other colleagues at the Times, and we put together this. We call it an illustration. I don't know if I would say it's a simulation, but it uses data. It's wind. We use wind speed, direction, cloud height. There's a certain height that fog kind of goes to, and then elevation, and then ran this fluid simulation. And I was really pleased with how it came out and how it illustrated. You really can see the the parts of San Francisco that are kind of consistently foggy, and then how it kind of spreads throughout the Bay Area. And then I just had to include this. I get this really wonderful email from one of the USGS scientists, who's kind of the fog person, and made the fog map of the Bay Area, which is the one, and they said the best teaching aids I've ever seen for fog dynamics in the Bay Area, and oh my gosh, this person has devoted their life to this subject. And like I said, I came in blind to this and kind of worked my way through it, through the process of making. And so that I felt really wonderful about that. So I just want to thank you guys. Yeah, this is my cat Tilda. Here's my contact info. And this is my first NACIS conference. And so I'm really looking forward to kind of meeting a lot of you. And anyways, feel free to reach out. And thank you so much.